Good morning. Welcome to basic troubleshooting of imaging equipment with the emphasis on basic. If you've been doing this for a while, you're going to be bored out of your skull, so feel free to sleep or whatever you want to do. I've got a long script and I can do this by myself. I've been doing that for a couple months anyways, but good morning. Okay, now you're not going to work.
You just pulled it to sleep.
Yeah, I did, didn't I? All right. Okay, we'll do it that way. Just a little bit about me. I got my start on copy machines. Got to work for 3M. If anyone remembers when 3M did copy machines. Then I graduated Xerox, went to work for the Navy. Then when I got out, I was lucky enough to work for Siemens for over 10 years on everything but therapy. And today I work for Technical Prospects. First topic is basic troubleshooting, information gathering, process of elimination, staying on the right path, and not getting on the wrong path. All right. Make sure you have what you need to safely troubleshoot the equipment, including documentation and service manuals. It's important that your tools and test equipment look professional. The site's confidence in you partially derives from your appearance and tools. Safety, that's your responsibility. This is a picture of burns from an MRI cold head. He just barely touched it, and he wasn't wearing gloves. Can't do that. Okay. Like a lot of people, I know someone who shocked himself. He was working on the rear of a CT gantry. He was going to go measure a switch near the slip ring. He was not wearing gloves, and his hand slipped, and he touched the ring. It happened over 10 years ago. He wasn't fired, but no one forgot the incident. They never did. And he wound up leaving a year later just because of that. Anytime later someone mentioned him, they didn't call him by his first name. They just said, oh yeah, Sparky. Wear your personal protective equipment. If you have any doubt that a hazard exists, it does. Don't be complacent. No one's going to care about your health and safety more than you. All right, something that's generally not talked about, but if anyone reports a patient, technologist, or anyone else was injured in any way, such as experiencing heat from a coil, a part falling off the equipment and landing on a patient, or someone slips on fluid that leaked out of a part onto the floor, it's all happened within the last 2 years. If anyone was injured, don't go any further. Take a few steps back. The original equipment manufacturer will probably have to go to your site and collect logs, pictures, and other pertinent information. So just make sure you get the okay before you proceed. All right. What the operator's thinking. One thing that's very important when you service medical equipment is your relationship with the department director and the technologist. Having a great relationship will go a long way. No one's perfect. I'm definitely not. We all make mistakes. There are days when the issues are taking way too long to figure out. If they like you, they're more likely to give you some slack, especially if you have a good reputation, which you do control. Important thing is don't ever denigrate the equipment or the manufacturer. It's only going to give them a bad impression of you. Instead, listen to them. Let them finish. Don't talk over them. And try to get them to be as specific as possible. I'm a big believer in taking notes. You may want to go back over them later and review what they said, especially if you've been working on the issue for a while and decide to start from the beginning. Can you verify the issue? Whoops, wait a minute. All right, we're having fun with this thing this morning. Okay. I'm really sorry about that, guys. Backups are very important. If you don't have a backup and your system crashes, it could be the difference between an hour-long restore or 2 days. If you get to the site and you're not sure if you have a good backup, go ahead and do it. There's a ton of ways to do it. We can talk about them later on, but it'll really pay off in the long run. Okay. Monitors are one of the easiest issues to troubleshoot. If the monitor has nothing on the screen, look for a small power on LED that'll be right about there. That'll tell you it has power. If you have any doubt, just measure it. It's just regular socket going in. Some work off of 110, some are working off of 220. Doesn't matter, it's all the same. You can unplug it and just measure it. If you have power, you see a default splash screen when the system boots up. If you do see a default splash screen, then the monitor has capability to display images. One of the things I did when I was in the field was I carried a spare monitor. I could easily install it in place of the original monitor. If the monitor I brought works, then the original monitor is bad. If my spare monitor didn't work, then I'm checking the cables, the graphics cards, and the computer tower itself. There's one thing to be careful about when you look at how the image is on the monitor. Before you calibrate a monitor, talk to the doctor and technologist. They may like how that image looks on the monitor. In fact, they may have told another engineer to set it like that. In that case, you should see some notes in the preventive maintenance protocol.
Setting along with
Sure.
others, just like
Well,
color balance or beyond
sure.
that?
Well, let's suppose you go in there and you're troubleshooting and you go, wow, that image just doesn't look right. I think I'll see how it calibrates to see how good the contrast is. Doctors and technologists are usually pretty fair, but they're very particular, and I don't blame them because they have to diagnose this stuff. This comes from experience. They had an image quality issue, and I looked at the monitor and said, wow, okay, that's pretty bad. So I went and calibrated, and then I fixed the problem, and they said, nah, I still don't like the image. And I said, I just calibrated. He goes, well, that's your problem. I like it I like it at whatever percent density. So I spent the next hour, getting it back for him and realizing, okay, maybe next time I should ask you. But yeah, they're very particular, and I don't blame them. Well, after that, is your computer having issues? Is the tower not turning on at all? Easy thing is to check your incoming power. If it's good and the tower is still dead, chances are the power supply is bad. You can just check a couple of outputs to verify it. Do you have issues sending to PACS or getting the work list? You can try pinging another computer or using a laptop computer to check the network card. If the computer is not booting up all the way, hopefully you have a clone or a ghost or some form of a backup. I would run a hard disk test before I restored a ghost or clone backup. It's very frustrating to install software only to find out that the hard drive is bad and you just wasted all that time. With computers, you could even have a BIOS battery issue. BIOS batteries should be replaced at regular intervals, but they don't always get replaced. The best symptom of a bad BIOS battery is you can't keep time properly. You'll see the time keep jumping around. All right. Now, if the computer boots up all the way, but the operator can't scan, check the databases. When databases get full, the computer's going to have issues. And the problem here is there's more than one way to delete patients. So the operator could be deleting them wrong and not even know it. So if I have any doubts, I'm going to delete the databases and start fresh. But one thing is let the operators know and remind them when you delete the databases, it's all going to be gone. There's going to be nothing left and you can't get it back. And I've done that when the operator said, okay, and then they ran back in and said, did you do it? Yeah, that's a real rough time because you can't get them back and they have to rescan. All right. Once you're done with that, what do you see when you enter the scan room? Is anything out of place? Is there fluid on the floor? Is the room temperature good? Some medical equipment will not function properly if the room doesn't have a specific temperature or humidity. MRs and CTs especially, but some other stuff, it just won't work. And you'll spend a lot of time and you won't understand. And so sometimes it's just good to check the temperature when you walk in. Do you smell anything unusual? Or did the operator tell you they smelled smoke? Can you tell where it's coming from? Do you feel anything warm or hot? When you open a cabinet, do you see fluid dripping or anything? Is there dust everywhere? Dust caused from patient gowns can be a huge problem in power cabinets. Power cabinets and components should be vacuumed at least every preventive maintenance. Okay, come on. All right. When you go into the power or generator cabinet, do you know what LEDs should be lit? It's a really good idea to take a picture of the cabinet and the LEDs when it's working and place it on the inside cover. That way you have a quick reference. I like to tape a picture to the inside door. I can easily compare any lights or LEDs that are not on, or any lights or LEDs that are on that should be off. When you're looking at LEDs, remember, red does not always mean bad, and green does not always mean good. We've always called this the engineer's joke, where you would see a red light and think, oh, okay, I got a problem here. No, it's better than it was, but it used to drive most of us crazy. Another thing, are the fans turning? Do they sound different? Is there any other things in the room that sound odd? Do you notice any cables that are unplugged? It's a good idea to label cables that are not normally plugged in. Sometimes the original equipment manufacturer will have spare cables in case one wears out, especially if the cable would take hours to replace, but no extra time when the equipment's installed. Also, when updates are done, cables can be added or become unnecessary. So a cable might just dangle there and you might think you found the issue when you see it. This is especially important when you've been working on the issue for a long time and you're tired and you're easily fooled. The best time to label cables and anything that looks out of place is when you're performing preventive maintenance. All right. If you don't see, hear, or smell anything unusual, it's time to look at power. This is something odd, but I've actually found in medical equipment, it's happened. The incoming cables will vibrate, so they'll get a little loose, and you'll have issues you won't even see. So if I'm up to measuring power, I'm going to turn that breaker off, and I'm going to go in and I'm going to tighten the cables. And then I'm going to turn it back on, and I'm going to measure incoming and outgoing power. Most of these systems have 3 AC lines a ground, and a neutral. So you could have power to the cabinet, but you might have a leg drop out. It's more likely that you have a neutral line issue. I've seen neutral lines that were held on by a screw, and they were either loose or they came off completely. I once had a neutral line with 45 volts on it. A neutral or ground issue will cause a lot of bizarre issues, including tubes wearing out prematurely. So measure them. It won't take that long, and you might be surprised at what you find. In one instance I had, we kept going through tubes real quick, and every time I measured, I was fine. But I pulled the transformer panel, and there was the neutral just dangling. And I measured it on the other end, 45 volts. All right. Do you have a service key? I had the privilege of working for Siemens for over 10 years, so I can really only relate to how to do it with Siemens, but they're fairly similar. It's easier to get a service key from Siemens if the person calling is in the Siemens database. Usually in your imaging center or hospital, someone has a relationship with GE or Siemens. If you don't, I would have that person call and say, I need a service key. If Siemens knows you, they're going to give you one, which is called a level 4 for about a year. That's pretty standard. And if you get one, here's what you get. And this is basically a level 4, okay? But if you need to go into test tools, which is 5, you'll need to get a level 5. You can call them, and if you can justify that level 5 service key, you'll get a higher level for a few days. And I hate to say it, but it does depend upon what you're doing and the mood of the person handing out the keys. I've had the same person say no and yes to the same thing. Siemens is going to ask you for the hardware or dongle ID, also known as a host ID. Newer systems will have the number on the service page, and older systems, you're going to actually have to enter the last 6, and the ID number will pop up with wrong entered. They're also going to ask you for the functional. For Siemens, it's 400 followed by a dash and 6 digits. And it's really important because that's really the only way that they know the system, is that individual piece of equipment at that site has that number. And it's also important if the system moves, they have to re-register it so they know. Otherwise, they're not going to give you one. Okay, so if you get a service key, here's what you can do with it. And this is off of my company's Luminos Agile. The first one, this is just of an operator screen when you walk in. And basically, you go in and you hit that top service, and that screen will pop up. And basically, if you have the first 14, because it's a 20-digit, awesome. If not, you put in your first 14, and you hit that set as default box, and then you put in your last 6. Once you do this, you shouldn't have to do that again, just the last 6. This is the basic service screen. They're pretty much alike, but the buttons that are going to help you the most are this one, the event log, reports, help file, test tools, and tune up. Good time to practice navigating service softwares during preventive maintenance. This is the event log. It can either be a real big help or a major disappointment. Being familiar with how your event log functions will help. Usually, I just look at the errors. Warnings can be very general. Hopefully, after you double click on the error, you'll get some useful information. The next thing I do is I look at the explanation, which is just a basic sentence of what the system thinks is wrong. And then the action tab is going to tell you what to do, starting with most likely to fix the issue. Deciding what's relevant is the most important part of reading the event log. Here's another nice thing they have. It's reports. Reports will tell you everything that has been tested and calibrated. It can be very useful if you want to know what's been performed, if it passed or failed. So maybe you walk in and before you start, you want, someone says, oh, we've had this problem before. We've had the problem way before. You might want to go on and say, well, let me see what the previous person did. And did it pass or did it fail? So either you can save some time saying, well, they already did that, or you know what, that failed. So it's a big help. All right. In newer systems, using test tools, you can check what the system thinks the basic power supply voltages are. It's a good, quick check, but it's also a basic check. And it's not going to tell you what the power is on individual components, such as frequency converters, motors, and CAN components. But what is nice about it is it's measuring direct on your power supplies. So you can either see, okay, it's a little low, maybe I can tweak that pot, or, if these parts are good, I can move on. Okay. Hold on. All right. In test tools, stand test, you can check the control module and digital inputs for the digital imaging tower and the table. And I'm speaking of a fluoroscopy table, which is pretty much the most popular piece of equipment you're going to work on. You can check all the in switches and the temperature of the brakes and the motors, all the dead man grip and exposure signals. You can put the scanner into uncontrolled mode, which bypasses all the safety switches. So if the operator drove the table too far, you can drive it off the switch. Otherwise, you can't. In limit will show you if a switch is being actuated or thinks it's being actuated. You can test all the LEDs, CAN communication, motor controls, and your input and output to the boards, all with just this. You can do so much troubleshooting just sitting there at the console without really doing anything, which is a great investment. Before, you're measuring switches and everything individually. I still would if you find a problem, but it's a great time saver. Technology has really been pretty incredible. This is actually my favorite. It's called position check. And unlike being in tune-up, you're not calibrating. So basically, you're going to move everything, and you can watch the encoders and potentiometers, and you can see if they're tracking fully, or if maybe something isn't, or it's tracking funny. Back in the day, you'd have to actually hook up a meter and have it move and try and keep track with it. So it's a huge breakthrough. All right. Another basic check is configuration. You can see what's reporting back and what's listed and compare it with should be. If a component is not reporting back, you should check power to the component. But what's really nice is this just all populates and it just goes out there and says, okay, are you out there? You with me, tube? You with me, detector? It just goes through everything. And if it answers back, at least you have power and at least you have communication to the component. Okay, this is version check. And it looks at what software or firmware you should have and what you actually have. If you're installing a part and it's not going well, you can go into version and see what the status is. Version check will also let you know if a component is communicating or not, just like in the other one. CAN communication is also a great check. But remember, if a component fails to report back, it's either power to the component or the component. So check power in and power out. And also the problem is a dead component could make you think the next assembly in the CAN communication is the issue. So I'm always going to chase power first on that. Also, CAN communication has been around since the 70s. The automobile industry invented it, and now pretty much everyone in the medical industry uses some form. But it is important if you get a CAN error to take a look, because usually the part above it is dead, and it makes you think that the part below it is dead. All right. This is what I was referring to, position check in tune-up. The big difference is you're going to calibrate and set it. So it's actually, unless you abort it, you're actually going to calibrate what position it's at. And if you have any questions about how to perform a tune-up step or anything else, click on the help file up here, and it'll show you where you put a component like the table. If you need to calibrate a potentiometer, it'll pop up and it'll say put it right here, and then you zero out the potentiometer, you hit set, you're good. Movement issues are very hard to pin down. You have emergency stop buttons and collision switches. Emergency stop errors can be very tough to isolate. There's usually more than one emergency stop button, and most event logs don't let you know which emergency stop button is being actuated. So if you have an emergency stop issue, the first thing you're going to want to do is ohm out each button. It really doesn't take that long. You can also jumper them out, which will help you isolate the issue. Most of these tables use very thin wire for switches and anything carrying over 5 or 12 volts. Over time, those thin wires break from flexing over and over. Following wires down to the control board can be very tough. I once spent 7 hours replacing a wire harness in this same type of table that went from here all the way up. It took me 7 hours. It was very frustrating. I invented new words that day. But the basic problem is it's tough to see. Those wires are very thin. And older equipment, you're going to start seeing weird issues like that. Now, these safety switches will stop a table from moving. Original equipment manufacturers, they've changed a lot recently. They're using more of these safety switches because of problems with equipment operators. Unfortunately, this leads to more issues for you to repair. And basically the problem is this is on the outside. And we've had operators that'll put a stool under a machine, unfortunately, or just be careless, and then you crush something. So basically, this is a safety switch bank for Siemens Agile. There's 8 switches around here, and it's very thin metal that they're resting on. So the basic problem wouldn't be them actuating, but the metal would start wearing out and the switch wouldn't be adjusted properly. So you would get errors when there was none. And with this system, if one of those is actuated, you're not moving. It thinks that there's a collision, so you're not going to move. And basically the problem is if you get an error, it won't tell you if it's the right side or the left side. The machine's only going to tell you that you have an error. But one nice thing that Siemens did was they provided a jumper. So you can, you can see where that plug is right there. Instead, you can put a jumper on the machine and you could jumper it out. So you can isolate, if it takes it away, go, okay, my problem's with this switch bank. If it doesn't, you can pretty well say, well, that's not my issue. One thing to keep in mind, and this is the same switch, only an up close. You can see where you can adjust it, and there's that thin metal. That's the only thing it rests on. And you've got 8 switches there. So, yeah. but a safety switch will not keep you from making an X-ray. If you can get the components into the proper position, the operators can make an exam. These switches, however, can stop the operator from moving the overhead tube. Also, if the system will not move, consider operator error, because if the digital imaging tower, which is that top floral tower, is not in a park position, the movements of the overhead tube will be affected. It won't move. Also, if the tube is not in park, the table or the digital imaging tower won't move. And sometimes the operators just forget and they call and they say, I can't move the thing, and you look over and neither one's in park. So sometimes just a little, operator trainings in due. When we first started, I talked about a table issue an operator complained about. Most of them, you walk in and you can't duplicate the issue. One thing I started doing later on was adding weight to the tables, because I started realizing that these tables can hold up to 650 pounds, which is a fairly decent sized person. And it made a huge difference to how the table was. So I didn't do it at the start, but later on I started when they would give me, well, we got a noise or something. And one time I actually put 3 operators on the table, and the third operator, yeah, I heard my noise. So maybe then you'll hear the noise, see it vibrate or skip. Hopefully it's not because the machine isn't lubricated or cleaned properly. The motors for these tables, some of them use 300 volts, which is a lot of power, but even a little resistance can make them malfunction. And the reason for that is there's a motor controller there that's reading feedback. So if it gets any feedback, it's going to stop because it wants to protect the motor and not overdrive. So sometimes people are like, well, wait a minute, I got this huge motor. Why isn't it working? It doesn't take much to stop it. It really doesn't. We'll go a little bit over power issues. This is just a typical fluoroscopy table power cabinet. When the system's off, but the breaker's on, you should have power to a detector, or if it's an older system, an image intensifier. You should also have power going to your control box, so when the operator presses the on button, the system boots up. Power generally takes place in 3 steps. You have GS, or generator supply. It's going to take 2 of those legs, and it's going to take them to external devices, like your computers or monitors. You have LS, or load contactor, which is also going to use 2 legs to start what they call the charging circuit, so you can make X-rays. And then after those 2 are both good, then what we call PS, or your power contactor, is going to kick in with all 3 legs, and then power is going to go throughout the entire system. So if your cabinet did not boot up all the way, you can follow the legs through the relays to see where you've lost power. Yes, and usually then it'll break out, but yeah, basically what you have is your 3 main legs going in through here, and then it's going to spur off. Absolutely. Older systems, you're going to see relays fail. Relays are very, they don't break often, but if you figure 10 years is pretty good for a part like that. And a lot of these systems have 10 relays. One thing I did like to do is if I was lost, like here's a relay, and it's hard to see, but you can push that button in, okay, and see if you got power going in and then out. I would first measure the incoming to make sure, but if I'm not getting that relay to close, I'll use gloves because I don't want to be sparky, and then I'll just push that in. If I get power, then I'm immediately suspecting the relay. What's also good to notice though is there's usually things on top of these relays. So if you're going to order a relay, it's important to see, okay, do I have something else on top of it, or what type of relay? And sometimes there's little pots here that do timing. So you might get a relay, and if you don't set it right, it won't work because of the timing. A relay like that probably works in 20 systems. So the timing might be different on others. And unfortunately, it's millisecond critical. All right. Okay. When that generator or power cabinet is booting up, the table, overhead tube, and wall stand are given power. The rad stand module or CAN control board is looking for feedback from these components. So if all the potentiometers, encoders, motor controllers, and motors answer back properly, the CAN control is going to close and allow for movement. So if you walk in and it's booting up, but for some reason you can never move the table, I'm going right back to this guy, because this is the one that's going to say, give it power and actually generate power for that. So if you can't move it, I would check for a motor controller or something like that. Like with the other boards, I like to take pictures of the rad stand module and the circuit boards and put them in the cabinet. That way I have a quick reference of the LEDs and I can see what they look like when they're functioning properly or in standby. And with this one, if you notice, it's kind of hard, but these LEDs are not in order. Also, this one's lit, that one's lit, and these three are lit. And you'll see as it boots up, different lights come on. So it can really be confusing when you walk in there and you don't know what it should look like. And all of a sudden you look, well, why isn't that LED on? So I really like to take a picture of that. And basically, here's what one of my cabinets looks like. There's that rad stand module or CAN communication, and there's what these boards look like. And there's that guy up there. And that's actually the jumper that's used for the digital imaging tower safety switches. So it's all there. And I know some people get worried about, well, the operator can mess with that. You need to have a little special key to get in there, so you got to trust them a little bit.
Any issue with fire safety, having bigger products inside the house?
Never thought about that. Luckily, well, no. I tell you what, if it's going to blow, it would probably stay to the cabinet at least, but it would make an interesting smell. I've never had the fire marshal get me on it though.
And they're never
But-
crispy or
Not yet.
toasted by the time you look at it.
Not yet, but there's always a first time if you're working on this stuff. You know, I've seen a lot of weird things. I've seen that CAN board, that rad stand, I've seen updates blow that part up, software updates. I've seen a lot of strange things. I believe in everything, including Bigfoot's a possibility after spending 10 years doing this. Now here's a little bit of a more delicate issue, image quality issues, okay? If they're complaining about the image on the monitor, that's the time to calibrate. Okay, that's a good time to say, okay, well, it looks garbage, I'm gonna calibrate it. I would ask them is the image consistent with this monitor and another one? Because chances are the operator's console is not the only one being used. Usually they send to a PAC system. Usually the physician's actually not even there. They're sitting in this dark room. It's kind of like a forbidden room. You don't even go near there. It's like kind of awakening a bear who's hibernating. So their monitor might look totally different. But at that time, if it doesn't work, absolutely calibrate it. After that, what's your KV or MA? The doses for KME, KV, and MA should be checked during certain preventive maintenance cycles, usually every 2 years. If the doses are good, but maybe we have what's called an automatic exposure control, okay? Operators have the luxury of not having to do anything. They can just pull up and say, okay, I'm going to do a skull. This is the patient's weight. This is their gender. This is everything. And then it decides what to do because you have this nice little chamber back there. And basically, that's like film. It's choosing the speed film. So if one of those isn't working, they're not going to be able to do it automatically. And they're going to have to figure out how much time or KV or mass to use. So if that happens, you're going to want to look at that guy. All right. So if all that's good, it's time to take a next step. Now, if you have a digital system with a detector, you're going to want to make sure that there are no dents, scratches, or contrast, or any other media on the table. There's something called a barium shield underneath, which is supposed to keep stuff off of there. You're also going to want to check your wall stand. If in doubt, I'd clean the surfaces because those dents will show up. And if you calibrate, then it's going to show up forever. So anything that's wrong is going to show up. Now, I've had a lot of people ask, well, what about discoloration and stuff? That usually isn't a problem. It's usually just stuff like dents, or maybe they had a little contrast spill, or maybe got a little bit on the barium shield. So I'd be very careful before you do that to make sure you don't have any of those issues. Another thing with detectors is some of them require you to wait hours before you can calibrate them. They don't want any exposures on there, any radiation after you've made x-rays. So be familiar with your time intervals. Some don't care. I've had some that are 4 to 8 hours. So sometimes I'll do a PM on one, and you want to do doses first, because why do a calibration then doses? You want your doses good and then do a calibration. So usually it's a 2 to 8 PM. So I'm going to.
Is that typical for both CDR and DR?
No, because cassettes you don't got to worry about. If you're talking about the cassettes and film, no, that's totally different. Now, with film, basically you're going to want to use a step wedge in quality control, because the problem is the film gets old and wears out if it just sits there. The cassettes are good, but you're generally not going to calibrate them. It's all the rest. Either it's good or it's bad, which is nice for you, because then you can prove with other film or another cassette, you're out the door. Your problem, not mine. You know, it's only with cassettes. Let's see. And the others you have, and most of these are, this is an analog system with an image intensifier. And a lot of those will also be older, will use film. Film's kind of still around there, as are cassettes, but luckily they're kind of a dummy, because detectors, while they're really expensive, about $105,000 for a detector, they're very reliable and very easy to deal with. If you got film, you got to go to their little cabinet and you got to get that, and then they got to process it and everything. So much better. But if you have an analog system with an image intensifier, you're going to want to check voltages. There's a little power supply, usually like right there, okay? And there's a test certificate that comes with every image intensifier. And you just basically go in and adjust it. And like any power supply, they're going to vary a little bit. So if you have an image intensifier, and you'll know because that's a pretty big thing standing on top, okay? You'll know. The first thing you're going to want to do is see how your power supply is, because it'll throw everything off. And after you do that, you're going to want to perform what we call light adjustment, because basically that's what X-ray is. It's light. And basically what comes out of there is radiation in the form of light. So you're going to want to perform a light adjustment. And basically light adjustment is done on a PM right after doses. Okay. Now, if you have a problem with an image intensifier, that you're going to want to isolate the issue. You're going to want to use a mirror to see if you have a bluish light coming into this camera that's mounted on top of that image intensifier. And yeah, that's actually just a regular camera. It's expensive. Those things are about $10,000, so they're not a standard Kodak or anything, but it's a standard camera. And I was really shocked to see that they actually just wear out, even though all I see is a lens that focuses. But I had them wear out. But you're going to want to see if you have a little bit of bluish light coming out of there. Now, if you don't see the bluish light, and that's kind of an example of what you'll see, it'll be a bluish green light. then you're going to want to take that camera off and use a mirror to check the light. If you don't see the light, the camera is the issue. If you see a light after taking the camera off, then your camera's the issue. Piece of cake. There's also a gray filter that goes with the camera that goes in and out. I've had those, so sometimes you can just take that camera off or look and see the gray filter sticking, and you'll see if you've solved your problem. One thing to remember, don't look directly at the light. I have a buddy who worked on these systems for years, and he got non-Hodgkin's lymphoma because he was just the type, he would just go in and look and get real close and forget, and that's real radiation. And luckily he's okay, but he doesn't do that anymore. From there, once you get the light, all you have is some analog to digital boards where it'll take that light and convert it from an analog signal to a digital signal. So basically, then you've got two boards, and basically just check input and output is all you can do. Let's see how we're doing that time. Okay. All right. All right. Now we're going to talk, okay, there it is, cool. A little bit about preventive maintenance. When you're working on a system on a regular basis, preventive maintenance can be your best friend. A properly performed PM can uncover problems with the system before they cause the unit to fail, preventing unnecessary downtime for your customer. And believe me, if you go in and do a PM and you get a couple months out of a system, they'll remember. Next time they see you, they'll remember. They'll know, hey, they came out, they did a fantastic job, we didn't have a problem for a couple months. That person knows what they're doing. And if you're unlucky and have a problem happen the next day, yeah, they'll think the opposite. But prior to any PM, you're going to want to ensure your test equipment is calibrated and in good condition. You're going to want to make sure you have some updated PM instructions and what we call protocols, and I'll show you that next. And when you fill out the protocols, you're going to be entering your test equipment, including your serial numbers and calibration dates. You're going to want to have all your parts, lubricants, tools, and cleaning supplies you'll need. The original equipment manufacturer provides a list of what parts are needed. It's not a suggestion. And the thing is, when they come up with a preventive maintenance program, like with anything that you're going to see in a hospital, vacuum pumps, it doesn't matter. That manufacturer has to go to the FDA and say, this is how we want to take care of the machine. This is what it's going to need. They actually have to fill out forms if they want to amend it. So when you're looking at these documents, if it says replace a part, replace it. And before a PM, I'm going to want to visit the site and see if there's any service documents, see what the software level is, see if they have any backups, if they're any good. I'm going to ask the operator if they're having any issues, because sometimes, especially if they know you, they'll have minor issues and they'll go, well, they're coming to do a PM in a month or so. I'll just let them know. So it's a good time to talk to them, maybe take some notes. And then with a lot of preventive maintenance, when you're doing a fluoroscopy or x-ray cable, it's 2 whole days. So you're going to want to negotiate how much time and when you're going to do it. CT's 4 hours, so usually it's a lot easier. You just walk in, I need 4 hours, and you're good. The thing with PMs, you can always do more. You can always figure out more things to do, but you can't do less. So if you have doubts, just ask them. A little bit more time. The governing bodies like the FDA and JACO, they're going to look at all your service records, but they're going to scrutinize preventive maintenance the most. They expect to see issues, and when they don't, they're going to, something's wrong. Now, granted, every PM I didn't, but if I had even a slight issue, I'm noting it. That way, when they came in and inspected what I was doing, I would say something like, okay, step whatever failed, perform such and such, recalibrated system to now inspect. We'll look at it and go, okay, at least you did something. If they just see, okay, okay. Okay. Now, I'm sticking again with what I know, which is a Siemens Luminos Agile. And here, a lot of things are weird about this is the terminology. Don't let it trip you up. Part of when I train in class, I spend almost an entire day going over all the different terms and abbreviations that Siemens does because they make no sense whatsoever. But basically, your work time here, it's only as a reference or an estimate, but they'll throw stuff in like work time. Well, all it is an estimate of how long it's going to take. Now for this one, most X-ray fluoroscopy tables, the interval is 24 months, which is good because you basically have 16 hours if you have a full system with an overhead tube and everything. So it's good that you have 2 years to do it. Some people will come in like June and say, hey, how about you give me the system for 8 hours and the operator's fine. So you just need to break it up in the right 8 hours, and then maybe you come back June next year, they give you the system for 8 years. 8 years, okay, sorry. They give it to you for another 8 hours. So you get the PM done in 2 years, you're good. They gave up the system, you know, for 8 hours one year, 8 hours the next, and they're pretty happy. If I do go in there and I'm doing 8 hours, now I'm not going to see the system at least preventatively for a year, I'm going to clean up and vacuum the system because, you know, they might not notice how horrible the system looks, and some people just forget. It looks like NASA's been using it as space junk. But when you leave, they'll notice. I never considered myself any more talented than anybody else that was there servicing. But one thing I learned quickly was I went up to do a PM for another area, and I always wipe the top of the cabinets and everything off. I just get the dust off. And I got a call from the director of radiology, and I was beside myself because they weren't even there when I did the PM. And they said, thank you for doing such a great job. Okay, cool. And finally, I went to the site a little while later and I said, I don't know how he knows. He said, because he went around, he saw how clean the machine was. That's it. He spent 10 minutes walking around. He put his fingers over ledges and he saw it was clean. He said no one had done that. Okay, good to know. Now, this is just a basic preventive maintenance document. They're really pretty long, but it's important to read through it before so you know what you're up against. Like with here, this is the generator portion or power, and Siemens actually has a part number for WD-40 for their engineers. They also have the stuff Hakapur, which will throw people off. It's Windex. So you don't have to order that from them. You can just, or call us or somebody and say, well, what the heck is that? It's Windex. Yeah, it's Windex. Hakapur. Yeah. It's their version of, it's a very expensive bottle of Windex. We have PM kits. We just use monitor cleaner when we ship ours out. I've always found it interesting that they figure you can get your own alcohol here. But do notice that they, and I don't know how clear that is, it was clear in mine, they urge you to wear rubber gloves. I always would wear gloves when I touched these machines, even when they were very clean. Not just because of everything, but, you know, old machines, I never touch those without it. And usually there's a whole bunch of gloves there. If they got a problem with it, all you got to do is say, okay, fine, this machine isn't clean up to standards, so how about you go get housekeeping? Guess what? They'll turn around and go, no problem, here's a here's a pair of gloves, don't sweat it. And there's also a little note here about vacuuming, okay? And really, unfortunately, it's one of the first things you can forget to do is vacuum all the dust from the machine and the cabinets. One time I took a service call after a buddy of mine performed a PM. He actually did a fantastic job. It was a 2-day PM. The guy worked his butt off, but for some reason, he didn't vacuum a power supply that was way back in the cabinet, which is probably because he didn't see it. And this to me goes as far as you can always do more, because even though this is an over 100-page document, Siemens never says vacuum every power supply with pictures and everything. They just kind of assume. So he didn't vacuum the power supply, and 2 weeks after the PM, which was time and materials, so the customer paid for the parts and 16 hours of labor, the power supply died. I knew the biomed manager. He followed me right into the place. I opened the cabinet, and there was a thick coating, about that much of dust on that fan of the power supply, and it was dead as a doornail. And he just looked at me and he said, well, what do we get for 16 hours? He didn't believe it. You know, we comped, and the part wasn't a big deal for Siemens, but you know, the unfortunate thing is he thought the guy was worthless at this point, because that's all he knew. He didn't know of everything else, you know, he did. Now, for these type of systems, you're going to need copper that's used as a filter when you're doing calibrations. So what they're telling you here is you want a plate that's 2.1 millimeters of copper, and they also have a set of 10.3, which make up to, 3 millimeters, and they have part numbers. You're also going to have a multimeter, and they're really not that specific about it. You just need a good multimeter. And this is just for this portion, the generator. Another thing is they have paint, and they have two types. They have the spray paint and they have the stick. I wouldn't use the stick, because basically the covers start looking worn out and old. And then if you're going to cover a scratch with a little paint stick, it's going to look like a tiger, and it really looks like garbage. So if I ever had to do anything like that, I just grab a spray can and I paint the whole cover and it look really sharp. The parts are listed right under here under required materials. It's just another thing they do. They're not going to say parts.
Does Siemens issue updated PM procedures?
From time to time, but I've had some that they didn't update for 7 years. It's really weird how they do that.
They never do.
Yeah.
Okay.
And we have a lot of them. We haven't been able to update in the last few months, but they don't do too much. If they do anything, like at one point they changed the interval that they were changing brushes for CTs. They went from replacing them every 6 months, which was excessive, to replacing them every year, or others depending upon it. But I don't know of any other. But yeah, they do. And you can call us if you have any questions. We have all this stuff. Okay, yep. All right. And here it just tells you that the maintenance interval is 30 minutes. And it's kind of important if you go into each chapter, so kind of read ahead. It's going to tell you it takes 16 hours. Most people, like I said, are going to divide it into 2 days. It just doesn't matter. As long as when you're done, everything that you needed to do is done. And now we'll get into a little bit. They do a lot of things that don't make sense to people at start, but really everything kind of, when you get into it, makes sense. This is just a radiation display check. But what it does is it ensures that you're seeing that the bell sounds when you're making radiation, that it puts out a little signal, unless the operator wants it turned off, and that the displays all come on. You know, sometimes the operators forget, they don't notice it, they get used to things, so you walk in and go, well, wait a minute, you do that check and you can make sure that the bell timer's going off and the light's going on. But it's just a real simple check. Now the last part for the generator, to me, is the most important part. You're going to adjust the X-ray tube. And as I showed with reports, it's going to be stored there. So whatever you do here, it's going to go in there. So the problem with a PM is if you don't do something, it's not that hard to figure out. If you say I went ahead and adjusted the tube, but you didn't, it's not going to be in reports. So it's important that you do it. Plus, it's really underrated. A lot of tubes will last years, if not a decade, especially in fluoroscopy and X-ray, if you just take care of them. It's a real simple trick. Okay, let's see. Okay, this is a much bigger chapter. The interval is 4 hours for this whole thing, but notice what's changed. For this chapter, now you've got all those different tools, measuring devices, greases, all that stuff. And you need to make sure that you have 4 hours to do it. Okay. Now, when it talks about torquing, make sure you have a calibrated torque wrench. And it doesn't matter who you have it, who torques it, as long as they're a reputable company, which there are a lot out there. And the problem with that is it's telling you to torque this at about 50 newton meters, which is pretty nice. There's only 4 bolts holding that. That's a table base. So that's the base, and then on there goes the entire table, and maybe someone who's 650 pounds. So if you're not torquing that thing, or if those bolts are out, you could have that whole thing rip out. I once took a service call when the operator tilted it way too far. It went way past the point of no return. And I've never received a call at 2 a.m. from technical support, but I did that morning, because they called and said, well, we just want to let you know. Number one, if you tilt it the wrong, if you go any farther, it's going to rip it out. Number two, if those bolts aren't torqued right, you're done. So they told me the first thing you need to do is go in and make sure your bolts are still torqued in there, because if they're not, that thing's going to tilt and you've got about 2,000 pounds coming at you. So that was fun at 2 a.m. It was a lot of fun. Okay. The safety switches, they need to be adjusted properly. So the unit doesn't drive past what we call mechanical limit, but just as important, that it can drive to the software in limits. And sometimes it's like that much. You know, it's not much, but that's something you do in preventive maintenance. Most of these switches, you can slide a little bit and give it some leeway, and you can do some calibration, because let's just suppose you calibrate a potentiometer, but you didn't put the component in the right spot. All it knows is it's starting from this spot, so it might try and go all that way. You really don't want it to hit a safety switch. So you want everything to be adjusted properly. But you also want to give the operator full range. They'll notice that too. Okay. Sometimes the notes are very important. And this one, it basically talks about the bearings being linear, which means they're going to rotate in this casing. And for all the money that was spent on building this machine, it's plastic. So you have a bunch of tiny, tiny bearings just rotating in here. So basically, if you put more than one squeeze or grease in there without exercising it, it gets clogged up and it's going to bust that thing. And you're going to have to order a lot of tools and probably take you 3 days to replace that thing. So it's important to take a look at the little notes and just realize it. Yeah, put a little squeeze in there, rotate it around, put one more. If everything's good, you're done. I know a lot of people think that more is better sometimes. Not always. Not always. Okay, in addition to other function tests, they're telling you to check the image tower control and all the LEDs. And it's another great time to find a problem that they didn't know, because sometimes they mightn't even realize that you have an LED out or something's not functioning because they're just in autopilot. So that's a real nice test. And then you find something, you can say, okay, in the comments, I found this, and either I corrected it or I'm gonna correct it. So a lot of the stuff pretty good. Okay. This chapter, they're talking about a spring balance. It's basically a calibrated spring scale. And if no one's seen it, you're basically seeing how much force it takes to move an item. So you got a spring at one end and a hook, and you hook it to whatever item you have, and you pull it, and it's going to show you a scale. And it's basically going to want to move at a certain part or stay stationary through that part. So in this case, they're telling you you're going to need to have a 100 newton meter scale for this chapter. And okay. This one is for a monitor carriage, and being Siemens, they also call it a monitor cart. So might be confusing to people, but it's the same thing. And they're only giving you 10 minutes on there. So it's important to go through and add up your time and see, because you might not take but 5 minutes on it, or you might have problems. You might have 15 minutes on the thing. And with this chapter, you might want to perform it at the same time as you're doing like a collimator, because you need that tool. So unless you carry one regularly, you might just want to look at the whole document and find out, okay, these are the chapters I need a spring balance, so I'll do them all at the same time. Okay. This step is very important. You want the rails to be tight. They do come loose, and it's most likely to go loose, because that overhead thing is just going back and forth. And generally, they're not going to fall from the sky, but if this is loose, it could have a tendency to go inward, and if that thing falls, it's a bad day. So it's really good to just check. What the heck, if you find out it's not right, note it. Then they know you did that. Okay. Now with this wall stand, it says it requires a spring balance between 30 chapter, which is nice to read on. You'll see that really the problem is you only need a spring scale that goes up to 250, because Siemens, for their engineers, has one that goes up to 100, one that goes up to 200, and then one that goes from 30 to 600. So you don't have to get a 600 newton meter spring scale for this. You can find one that does 250 and you're fine. Okay. Now, if you notice, don't use WD-40 on the rails. I'm sorry, use them on the rails, not the bearings. A lot of people out there seem to think that WD-40 is used for lubrication. It's a displacer for corrosion control. And if you're using those bearings, it's going to be bad. So this is one of the nice notes they put in, that you don't put WD-40 anywhere but on railings. And also sometimes you will see some corrosion there. Don't feel like you need to put sandpaper or anything to get through it. WD-40 will probably be enough if you just wipe it on and then wipe it off. Okay. If you have a portable detector, it's important to check the portable detector connectivity, which is down here. Okay. Something like this will tell you if your detector is communicating, because that's the big thing right now is portable detectors. They're awesome. You can take that detector and put it anywhere in the room and you're going to get a shot, which is pretty amazing still to me. So that'll tell you how well it's communicating. Also right here, that'll tell you how your battery's doing. What do they call it? Okay, yeah, they call it something different. But right here, see how it's green? Yeah, that's pretty much a full charged battery, which is good to know. Because if you go in there and you see that you're doing your pre-site inspection and it's not fully charged, you might just want to plan on having a battery there. All right, same thing as before with this little spring scale or spring balance. Right here it says you're going to need one that goes up to 100 and one that goes up to 200. If you have a spring scale that goes from 0 to 200, that's all you need. Because basically all you're going to be doing is entering all this information in your protocol, which we'll look at next, so it doesn't matter. You don't have to have the exact tools or anything. You don't have to have Hawkapur. You can use Windex or anything. And you don't have to have 2 spring scales for this. All right. Now, something in fluoroscopy systems and X-ray systems is the overhead tube assembly. They also, and there's something up there called a drum. For these products, they have you look at them every 2 years and replace them every 8. And it's a pain. It's a huge pain going up there in the ceiling and replacing that drum. But they've really started to emphasize it, and it's being cracked down on. So if you're working on one of these and it's getting at 8 years or it's past that, you don't have to do it right then and there. A PM, unless the machine is down or something is a safety issue, you don't have to shut them down then. But if you see it's at 8 years, you're going to want to talk to the operator and say, we're going to need a day or so to replace it. Okay. And up here is just a picture of those rails. And those heavy assemblies are just sliding on this, and they're bolted to the ceiling. And it's only 50 newton meters. But every 2 years, you should check them. And I have definitely found some of those bolts that are not torqued at 50 newton meters. I don't know what happens. They become a little loose. Fortunately, there's enough of them there where if one's not good, you should be able to still torque them every PM. I wouldn't let it go. All right, this is an interesting one. Some of the newer systems use a belt tension, and they test it with a tension meter, which puts frequency, which is ridiculous to me because I was a band geek until the football coach saw how heavy I was, but I could never do a middle C or anything. So they actually had a tool in here where you would pluck it and it would give out frequency and read it. And that was my exact reaction. I was a Siemens employee. But you know what the good thing was? Every time I tried to order that tool, you know what they told me? It's out of stock. We only have 2. So when you're dealing with something like